Today we're going to be looking at the kinetics of the α-galactosidase that we're purifying from E. coli. To do this, we're going to look at a colorimetric reaction that shows the cleavage of a group by the galactosidase. To start out, this reaction takes place at 75C since we're dealing with a thermophilic enzyme. So I have this heat block warmed up to 75C that's we're going to be running the reactions in. Currently in this heat block is 600 microliters of our substrate master mix, which the TAs have prepared in advance for you. The substrate master mix contains the 4-nitrophenyl alpha-D galactopyranoside, which is the compound that the enzyme has activity on. And what that enzyme is going to do is cleave off the nitrophenyl part of this compound, which will then emit a yellow color, and that's what we will track as the extent of reaction. So while that 600 microliters is heating up to 75C, to start each reaction, I'm going to add 100 microliters of the dilute cell extract containing our galactosidase enzyme. For a blank, I'll be adding a sodium acetate buffer in place of the enzyme to act as the background. I'll then let each of those reactions go for a set amount of time, different amounts of time for each of the 8 reactions that I'll be running. And then to stop the reaction, I'll add 500 microliters of this assay stop solution, which is essentially just a alkaline mixture that's going to shift the pH and shut off the enzymatic activity. To further halt the reaction at the time point we want, I will then quench each reaction vial in ice. And then we'll go analyze that after each reaction is complete. So I'm just keeping track of the time on the timer here. This is a very time-sensitive reaction, so it's super important to start and stop the reactions at exactly the right time to get good data. With that note, we'll go ahead and get started.
So that was the shortest time point. He added the enzyme and then added the stop solution. So each condition will be a different time length as mentioned, and we will do them in series. So he's also preparing a blank that has no substrate so that we have a baseline for when we read the absorbance of the released nitrophenol from the enzymatic reactions.
While we have a quick break here, we're currently doing this with the 1x master mix solution that contains a 1x concentration of the substrate. We're also going to do this reaction with 3 other substrate concentrations that are more dilute, which will enable us to get a couple different initial velocities and thus generate the Michaelis-Menten plot. And that will complete our first round, first concentration of the enzyme kinetics. We'll analyze those on the spectrophotometer from here.
This is the spectrophotometer that we will use to quantify our alpha-gal reactions that have released the nitrophenol group. As you can see, here are our samples, and you can see that some are yellow in color, while the blank is clear. The spec has several components. This is the Peltier that actually heats and holds temperature or cools the sample port and the spec. Here we have it set to 25C. Sometimes if you're actively quantifying a reaction of an enzyme in the spec, you could set it as for like a thermophile up to like 70, 80C if you needed to. This is the spec itself. It has the inlets from the Peltier, and it has a sample area that you can put your samples. Here there are two cell blocks. You can see the one in the back in the video here, where the cuvette actually goes in that sample port. The spec also connects to the computer, where it reads out data, and we'll show you what it does for the results of a single sample. Here we're just reading absorbance. The program can do much more complex things for other scenarios. You can see the blank had a 0.090 absorbance, and now we'll show you for the first sample. And see, the absorbance is higher than the blank. And we'll continue to fill out the rest of these and report the values later.